So today I want to talk to you about a strange item that I purchased earlier this past year, actually two items, and its relationship to the evolution of raised relief mapping as part of the cartographic tradition. It's focused mainly around the mid-1960s, but I do end up talking a little bit about what came before in the later part of the 19th century and what's going on today. So raised relief mapping has been part of the cartographic tradition for several centuries, but cartographers, especially in the American context, have been most involved directly in two areas. The first is raised plaster relief mapping, which started really mainly in the 1870s and continued on until the 1930s. And the second is raised plastic relief mapping, the type of which you can still buy from Hubbard Scientific, these little kind of like flimsy maps that are raised. Now, what's so interesting about these maps is that not only, yes, are they in 3 dimensions, but they require a significant amount of time and energy to make them. You think of a plaster map, you have to make the plaster and make the frame for it, pour the plaster, wait for it to dry, color the individual areas of it, add labels to it, etc. Now, while this was improved upon with the development of plastic raised relief mapping, essentially you still had to make that mold that then you could mechanically reproduce hundreds of plastic maps from. And so the question that seems to have plagued raised relief mapping during this time period is how cartographers could produce custom 3D raised relief models quickly and cheaply. And these items that I purchased end up kind of speaking to that. So I found these two items. Actually, I was only able to bring one with me. The first is this little cube, which you can see up in the upper right-hand corner here, that has these little pins sticking out of it. This is some sort of display piece. And the second is a large, about 12 by 12 board. And while I was really intrigued by these, I saw them on a Facebook group that I was part of, ended up messaging the person who was talking about them and offered to buy them from her, and I was actually able to get them. And I was intrigued for a couple reasons. The first was that visually they're quite interesting. They're obviously modeling something. And the second was these two stickers that were located on both items. So the first one, which was located on the board on the lower right, says first 3D digital plotter, 1966. The second on this cube, which you can kind of see right here, I'm sure none of you can read though, says Spatial Data Systems Incorporated, Goleta, California. And so I was really interested in these because not only the visual element, but that they were temporally placed at a time in which geography and cartography were undergoing significant changes due to the beginning of the digital revolution. To claim to be something that is the first is obviously impressive, and as we all know, spatial means special. So this was something that I had to get. So I started to do some research trying to figure out what Spatial Data Systems was as a company. There's really not that much information out there about them. It seems as if the company grew fairly large throughout the 1970s, and by the mid-1980s had been purchased by another company, which was then purchased by another company, and I cannot, for the life of me, figure out who owns basically what's left of the company. But what I was able to find was this. It was the promotional literature for the machine that made this model, and the name of which was the Model 501 Spatial Data Plotter. And so some of the images that you'll be seeing in here come from that promotional material. So basically, the operations of this machine operated similarly to traditional, well, as we would see traditional now, but what then were modern pen plotters. There were you would enter in your X and Y coordinates, which would move it to the exact coordinate position on the board. And then for your Z value, it would drive up a piece of metal into the board, cut it off, and then move over to move the next one. We might think about this similarly to those toys that you push your hands into and play with, though obviously they're not exactly parallels. So there's a bit of serendipity in this as well. At the same time that I ended up ordering this item, I also was reviewing this book on patents and cartographic innovations, which happened to be written by Mark Lemonnier. So I was writing it, and using his methodology, I was actually able to find the patent that was made for this machine. The title of which was a three-dimensional wire plotter, which was finally approved in 1968. So using the methodology outlined in the book, I ordered from the National Archives the patent file, 65 pages of administrative records, all sorts of correspondence, and a variety of different things about the patent. And so what was interesting about this is that in doing some research on this, that there were 3 inventors, all of whom were centered in Southern California, all working in the aerospace industry. 2 of them were electrical engineers, graduates of Caltech. The third was a mechanical engineer who had graduated from Purdue. None of these people, in other words, were trained in cartography. And it shows in the patent application itself. Throughout the entire application, the word map or cartography does not show up at all. The word graph does, and so I'm interpreting that as they were subsuming maps into the larger concept of graphing something. Though it is very prominent in their promotional literature. So everything that's boxed here in red is related to some sort of map. And this population density, remember that as we keep going through. And so I want to read this quote from the actual patent file. It is difficult to construct three-dimensional graphs rapidly and accurately. Manual plotting of a point for a three-dimensional graph involves accurately locating the XY coordinates for the point on the board surface, accurately manually measuring a rod or other member so that the length thereof will represent the z distance, and attaching such measured rod to the board precisely at the point dictated by such x and y coordinates. This tedious process must be repeated for each of the many points on the graph, when the information to be plotted is stored in a computer, it is even more difficult to rapidly manually construct the graph. And so I read this line and I was like, okay, yeah, that makes sense. It would be hard to do this. Who would be doing this? There were geographers doing this in the early 1960s. So this is a photo, 2 photos of William Wartz. He was employed at the Harvard Lab for Computer Graphics, and in the early 1960s, he constructed a population map of the United States using pins. So I'm gonna take this out here and come over. So here this is an IBM printout that lists how long each of the pins should be and exactly where they should be. So here he is putting in individual pins. I think this is what you have graduate students for, I'm pretty sure, to do. Putting in these individual pins, which then he basically created a model. He put plaster on top of it, and then created this final model, which is basically a population distribution map based upon 1960 census data. And so, in other words, he was doing the same exact thing that this machine was created to work on. And this obsession with surfaces, as Nick Crispin describes in Charting the Unknown, went beyond Harvard. In 1966, Walter Tobler and his graduate student Frank Renz at Michigan were doing similar work. This is with a traditional 2-dimensional pen plotter, basically working to create a 3D perspective. And so the question that I had was this: why hasn't this item kind of shown up in the larger cartographic history? Why doesn't anybody know about this? And so I want to take a second to look at the specs of this machine. It's actually fairly advanced for its time. It can plot things fairly quickly. It has a decent resolution. It has a wonderful, attractive Formica countertop. I mean, who wouldn't want this? But even actually more seriously, it came with a special Fortran software called Pinplot that allowed you to work with other computer systems so that you could create these models. And what I really think held it back was, unfortunately, the selling price. In 1967 dollars, this would cost $9,500 to purchase. With inflation today, this would cost nearly 65 grand to purchase a machine that would push a pin up through a board. So there, I think that's probably why there aren't really many of these around. And so this is where I thought that this story would basically end. I would talk about how, oh, isn't this so cool, like an interesting aspect of cartographic history. Well, I happened to run into a distinguished cartographer this summer who was attending, who said that he saw this machine in action at the 1967 Harvard Conference for Computer Mapping, where SimMap, one of the first aspects, or one of the first GIS softwares, was introduced to a large number of academics. Really a very pivotal moment in the development of GIS as a discipline. And lo and behold, I went to the archives at Harvard, and there is one of the co-inventors, David D. Rutland, the president of the company and co-inventor, at the conference, presenting the Model 501 in front of people like Tobler, Monmonier, and many others, all of whom would go on to innovate in geography over the next 20, 30, 40, 50 years. And so it lends credence to the idea that there was something important about this machine and that it had an impact on people. Because as time goes on, we continue to see this 3D perspective continue. After Frank Renz completed his PhD at Michigan, he moved to Harvard, where he was also employed by the Harvard lab. He ended up continuing this work. He developed something called SimView, S-Y-M-V-U, which was a portmanteau between SimMap and visualization that you could buy to basically create these sort of perspective maps. And so this actually, I find this really funny. So this is, I believe it's population distribution for the US based upon the 1970 census. And there are two maps, and as you can tell, they're like slightly off kilter. The idea is that you can view this in stereo. In other words, trying to view this in 3 dimensions, unless you had you could have had the Model 501 just plot it for you. But of course, who was going to spend that money to do that? And then as time continues to go on, we see the ability to basically do 3-dimensional modeling on computer terminals as computer memory increases, as the ability to actually have computer screens emerges, and it just becomes easier to do 3-dimensional modeling on a screen. And so in a 10-year period, or less than a 10-year period, from 1964 to 1973, you suddenly have this ability to do 3-dimensional mapping on a screen. And with that kind of comes the end, as I see it, of 3-dimensional physical representations, or at least innovations in that area. Certainly Hubbard Scientific and whatnot were still making those maps, but you could not easily make a custom map of that area. And so putting them on this is just something that cartographers have been doing for a long time now, for over 50 years, and something that people are even presenting at this conference. And what I think is interesting is how we can consider how the Model 501 fits into a larger history of GIS and cartography. It seems to be the last innovation for creating quick and customizable 3D representations for nearly 40 years. And perhaps it is just attributable by the fact that it was just really expensive and people just couldn't afford to buy it. Yet it's interesting to think of this as a rupture in the cartographic process. How might the discipline look if this machine had been cheaper or had been employed by other people? Regardless, the claim that was initially on that slide that said that it was the first 3-dimensional plotter, I think remains true. I do think it is the first machine that was able to cross the divide between digital data and a physical 3-dimensional representation of it. And what I find that is interesting is that in some ways cartography is moving back into creating 3D representations through everything from 3D printing to virtual reality. In some ways, the pendulum is swinging back to trying to work in three dimensions and actually bring that into the physical world. And so with that in mind, I'd like to think of the Model 501 as an innovation far before its time with real parallels to what's going on in cartography today. And so with that, I'd like to thank Matt Wilson, my advisor at Kentucky, for his help with some of the Harvard connections, Mark Monmonier for sharing his memories and the cartographic patent expertise, and some of my friends back at Kentucky for helping me organize this presentation. Thank you.